Welcome all of you to this video of Maths Made Easy. Now in this video we are going to do the concept behind gravitation. I have already posted the sums based on gravitation. Now this is concept behind gravitation, how actually uh, what is gravitation, we will see in this chapter. Let's start. Now, you have heard of gravitation quite a lot. Okay, this is not the first time you are hearing about gravitation. You have heard it so many times. You have heard about gravitation, from why the apple fell downwards. So anything we drop, I drop this pen and it will fall downwards, it will not go up. So it goes towards the earth, anything. Okay, so that is, now we say it is the gravitational force which is pulling it. Okay, now earth has something called a gravitational force. Now what exactly is this? Let's see. Now in gravitation, actually, gravitation is something, gravitational force is something which is possessed by any body which has mass. Okay, so even here, I'll have two marker pens here. These two also has gravitation. Okay, these two also has gravitation between them. I'll talk to you about this later. So anything that has mass will have gravitation. Okay, so it is not that only the earth has gravitation, even this pen had gravitation. Okay, now what is exactly, if I have a body here of mass m and I have a smaller body here of mass m. Now there is a distance between the center of these two bodies, which is r, or sometimes we also call it as d. Okay, now these two bodies have a force of attraction working between them, and that force of attraction we write as F. Okay, now that force of attraction is directly proportional to the masses. Okay, so product of the masses means more the product of the masses increase, more the force of attraction increases. Okay, secondly, the second thing is this force of attraction is inversely proportional to the square of the distance between them. This is not radius, okay? This is not radius, it is the distance between them. You can also write it as d. So this is also, force of attraction is also, it also depends, is inversely proportional to the distance between them. In other words, I can say more the distance increases, lesser is the force of attraction. More the product of the masses increase, more is the force of attraction. Now what do we do here? We combine these two things and we write here. We write this. Okay? We combine these two things and we write this. Okay? So this is F is G capital M into small m by r square. Now where did this G come from? This is a constant. What is a constant? Now you have come across many constants before this. You have come across one very interesting constant, that is circumference of a circle is 2 pi r. Remember, this is always 22 by 7 pi. You know this. So similarly in here also this is a constant. What does it mean? What does this constant mean? It means that if I try to check this for different sets of, different two different sets of, this is one set of body, I take another set of m and m. Okay, or I take 3-4 sets of m and m and I check with their products, and I check with different distances also. Okay, so I check with one more a and b body, and then the distances are 1, and I check c and d body and the distances are 2, like that, with different bodies and different distances. Okay, I check this every time. Whatever force I will get, okay, when I get this force, I note down this force, and then when I see, that is, I note down the force, and then if I do this, F divided by m and r square, that is equal to g, right? So if I get the value of this with the different values of m, different masses and the different distances between them with their corresponding force, I will get what? I will get the same value of g. That is why it is a constant. Means I am changing all these values, I am getting this also different, but finally the value of this on calculating is coming to one same value, and which is g. This g is called, g is the universal gravitational constant, universal gravitational constant, okay, also known as the gravitational constant. Now if pi had a value 2 pi 22 by 7, this g should also have a constant value. And what is that constant value? G is equal to 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2. Okay, little difficult to remember. So in the beginning you'll find this little difficult to remember, especially because of this. But I will tell you a method to remember the unit. You don't have to learn this to your examination hall. You can make it, you can get it in your examination hall with the help of calculations. Let's see how to do that. Now here I just said F is equal to G capital M by R square. Okay, so let me keep G to one side, F into R square capital M small m. Now what is the unit of F? Unit of F is a Newton. What is the unit of R square? That is a meter square, because it is a distance square. R is in SI. We are taking everything in SI. This is meter square. This is two masses, so kg and kg. So I get Newton meter square kg to the power minus 2. Yes, Newton meter square kg to the power minus 2. That is the unit of G. Okay, so that is the unit of G. Newton meter square kg to the power minus 2. Okay, so this is how we can get the unit even in the examination hall. So I never remember this. I just do this and get the unit. Okay, this value you should remember. Now, as I was saying, any two bodies has a mass. Any two bodies has gravitation between them. Few examples. Okay, we have the sun, and then we have the entire solar system where we have so many. Okay, so many. This is the sun, and we have so many planets. Now all the planets are moving around this. The reason is again gravity. This also has mass, this also has mass. Okay, so that's the reason, Mercury, Venus, Earth. So we are here. So that's the reason. The reason behind this is gravity. Why these planets are moving in the circular orbit? Why? There is a gravitational force acting between the two planets. Okay. Now the sun is a bigger one, and so the force that it is exerting on this first planet is more. This being small is not being able to pull this that much. There is a force, but it is lesser. Now what happens? So the smaller one goes around the bigger one. Now the smaller one doesn't come and stick to the bigger one. Why? Because it itself has some force, even if it is less. Okay, similarly for us also, we are also pulling the sun is also pulling us due to gravity, but then we don't have the capacity to pull the sun completely towards us, since we are also pulling it. So therefore we are not going and sticking to the sun, so we are just moving around the sun. You can compare this with two children. Okay, one big boy and another small boy. Okay, one small kid and a big person. Both they are holding hands, and then they are like we do this, and they are moving in circles. Okay, it's like that. Okay, sometimes they play like this. They hold hands and then they are moving in round and round circles. Now what happens? Okay, now the smaller one goes around the bigger one. The reason being, this is smaller, so this person being bigger is exerting more force on this, and so pulling it around it. But then this boy doesn't come to the center. He stays at a distance. Why? Because he also is pulling this man. So there is some force between them. Force by this is bigger, force by this is smaller. Since force by this is smaller, he goes round because this has a bigger force. So he goes around the bigger one. Same thing happens here. Now the very same thing happens when we have there's the earth, and around us the moon goes, right? Moon goes around us, right? for the same reason. The earth has some mass, moon also has mass. There is a gravitational force acting between both of these, the earth and the moon. But then moon's force is less, so we are able to make the moon rotate around us, and we don't rotate around the moon. But the moon doesn't come with our pull, with our gravity, doesn't come and stick to us, because it is also pulling the earth. That is why, but since the earth is bigger, earth wins, it is able to take the moon around it in a circular orbit. So again, gravitation here. So we get to see gravitation in so many different cases. So now you will say that why, if there is, if there's a tree and the apple is falling down, why is it falling? Okay, why is the apple falling down, or anything we drop, it just falls down? Okay, anything we drop just falls down because the gravity, earth is huge and the apple is tiny in comparison to the earth. So the force of gravity of the earth wins, and this is able to pull it down. Force of gravity of the earth is so big that the apple comes down. Okay, so we neglect the force of gravity of the apple completely because it is negligible mass in front of, if compared to the earth. Okay, now then one question might arise, if I have two markers here, yes, both have the same mass, then why don't we feel any force of gravity working between them? Or the chair in front of me has gravity, the table also has gravity, but we don't see them moving towards one another or moving in circle around one another, nothing. Nothing like that happens. Why is it so? Okay, so let's answer that question. Here we have, let's say, one body. Okay, let's say we have a, marker only. Okay, or we have a chair, or we have a table, something, and we have another body here. Okay, whatever the mass is, as I said, if they have mass, they will have gravity acting between them. There will be gravitational force between them. But then we don't see them moving, we don't see them sticking, we don't see them rotating around one another. The reason is simple. The earth is very big compared to them. Okay, so these bodies, you can say, in a way, have been pinned down to the earth. Like the force of attraction of the earth is so big that they have been pulled down to the earth, and they don't have the capacity to move anywhere else. Okay, so here is a big force, the earth is giving a big force to these two, so it is pulling it so hard, it's like pinned down. Now whatever force is acting between them, they can't move. Okay, so that is the reason we don't see any body around us moving towards one another, because force of gravity of the earth is huge. Now if I talk about the moon's gravitational force, okay, so we have the moon here and we have the earth here, and there is something very interesting that happens between the earth and moon, you know that, and that is the, what is it? It is the tides. Okay, so what happens is, the earth has 70% of the earth, okay, over the earth is 30% is land, rest is water. There's a whole amount of water, so much of ocean, so much of water. Now what happens? The water level goes like this. Okay, so the water level increases in the side of the moon. Whichever side the moon is there, water level goes up, and the other two sides water level goes down, but here again water level goes up. Okay, now why it happens? Why does the water level go up here, and why does the water level go up here but does not go up here? What is the reason behind all this? Now this is the moon. Okay, now whichever side moon is there, moon is not being able to pull the earth because it is smaller. Okay, but then it can pull the water towards it. So it pulls the water towards it due to gravity. But then these two sides, okay, from here the water comes here, this places in this side experience a high tide. Okay, on the other, now you will ask, then why does the water rise there? Now the water here, the gravitational pull is more, so water can come, but here the gravitational pull is very less because it is in the opposite side of the earth. So gravitational pull is less, and now due to inertia, Okay, due to inertia, the water level does not want to move, and so the water level stays higher in these places. Okay, so due to inertia, water level will not move in these places, and it wants to. So due to inertia, we have the water from here does not come here so soon because gravity is less here. So the gravitation is asking, working on these two, working on this, but not working here. Okay, so that is why we have high tide here also, we have high tide here, we have low tide here, and we have low tide here. So this is what tides are. Okay. Now here I want to talk about the gravitational unit of force. Okay, in many of your sums you see this kgf, gf, right? In many sums. Now there's a little bit of confusion. Okay, see in SI unit the unit of force is Newton. Here it is dyne. In CGS it is dyne. In CGS it is gf, gravitational unit of force. This is gravitational unit of force. Okay, in this it is in SI it is kgf. Now how to convert kgf to Newton? Okay, supposing they told me 10 kgf, how to convert it to Newton? 10 kgf, if I want to convert to Newton, you can say this is a unit of force, but then force is equal to mg, right? Here this is actually only the mass with the g, not, in this unit we don't multiply the g. So if g is 10, or let's say g is 9.8, then if we want this in Newton, we'll make it 10 into 9.8, that is the value of g, Newton. That is 98 Newton. As simple as that. So you have to remember this value is actually the mass. In this unit we don't multiply. When we write kgf, we don't multiply the g, acceleration due to gravity. Without that we write. So here we have to multiply in order to get it here. If you want to convert gf to dyne, then we'll have to do, supposing this is 10 dyne again. Okay, this is 10 gf they have given us. How to convert it to dyne, that is CGS, unit of force. 10 into 980, because CGS, in CGS unit, acceleration due to gravity is 980 centimeters per second square. So here we will write 980. Okay, so this is 9800 dyne. Okay, so this is how we convert from gravitational unit to Newton or to dyne, because in many numericals you see it like this. Now what is mass? Mass is the quantity of matter contained, matter it contains. Okay, so, and what is weight? Weight is the force with which the earth attracts a body. Okay, the force with which the earth attracts a body is the weight. Okay, now many times we say, okay, many times we use weight instead of mass. Okay, but that is not right. Mass is a scalar quantity. Okay, mass we tell in kg, weight we tell in Newton, or okay, so weight we tell in Newton, mass we tell in kg. Now weight is what? Okay, weight is equal to m into g. Now if you note clearly, this is actually mass into acceleration. So F is equal to m into a, we know. So this is only that force which is pulling a body towards it. So the the force with which the earth is pulling us is our weight. Okay, so mass is how much of matter is contained in us. So if we go to the moon, okay, our weight will differ, because in the moon g is 1/6 of that of the earth. Moon's mass is less, and so g is also 1/6 of the weight of the earth, and so our weight also goes down there. Okay, so this is, So this, but the mass remains same even in moon. Okay, so mass will remain same everywhere, the weight will differ according to g. Okay, so here in the, on the earth, surface of the earth also, here it's little bit flat, here also it is little bit flat on the earth. Here the value of g is a little bigger and the value of g is a little, okay, g is little bigger, value of g is little higher here, and rest of the earth it is little lower. Okay, at the poles it is little higher. So if we go here, our weight might be little more. Okay, so F is equal to ma, from that only we got this. Now what is weight measured with? We take weight with the help of a spring balance, okay, and mass we take with the help of a beam balance. These days they don't use mass much of beam balance, but then if you have seen this kind of something, okay, this is a beam balance. Okay, so if you put a 1 kg weight here and then you put whatever you want to buy 1 kg. So this was a manual balance, it was held here, and as long as this comes straight, then you know that you have got 1 kg of something you want to buy. Okay, so this is called a beam balance and spring balance, all of us will be having. Okay, so it has a hook and then it has a kind of this kind of a thing with all markings here, and then it has a hook. On this you hang the thing, okay, and you take the weight. Okay, so this mass is a scalar quantity and weight is a vector quantity. Okay, this is a vector because weight has a direction. Actually, this is to, weight is towards the earth, mass is, has no direction. Okay, so these are few of the differences between mass and weight. So if I tell quickly, scalar, unit, how we measure it, does it change from place to place? Okay, and then the definition itself becomes a difference. Okay, so that is the basic difference between mass and weight. This is what the concept of gravitation was. Okay, so and based on this there are some numericals, okay, which I have already uploaded. So this video will clear all your doubts about gravitation. So that is it for today. Check for the videos in the playlist. There are lots of 9th standard videos uploaded in the playlist. Okay, and if you still have doubts, you can ask me in the comment section. If you haven't subscribed the channel till now, please subscribe it because lots of more videos are going to come up. Thanks then. Bye all of you.